Hello and welcome to another video. This time we're going to be looking at how we might use macros when we're assembling with the Easy80ASM assembler. We won't actually be writing any programs this time, but we will be looking at some examples. And we'll also be looking at two different reasons for using macros. The first reason is using for macros to generate code. We also need to consider what's best. Is it better to use a macro, or is it better to call a function? If we take this really simple example, a quick way of clearing the screen, those of us familiar with BASIC will know the CLS command. So effectively here we're creating our own command with a macro. We're doing all the things that we need to do to make the VDP clear a screen. We're loading A with 12 and then sending that byte over to the VDP to process. Using a macro here takes up 4 bytes, but it's not taking up any more than just simply writing that code out within your program. But it provides us with a convenient way of simply typing CLS to clear the screen. If we compare that to calling a function, we can see that there's a difference in both the number of bytes used and the time that it will take. Calling the CLS function takes up 4 bytes. Assuming we're in ADL mode. The next 4 bytes are the same as we've used before, but we also need to add a return call. There are also 3 bytes used to push the return address onto the stack. However, if we're going to be calling this routine multiple times, each time it's called, it only takes an extra 4 bytes. If we add those bytes up, say over 10 times within our program, then the macro took a total of 40 bytes, whereas the function would take more still. It would take 45 bytes, plus the 3 it uses on the stack. So at the end of the day, the macro here is faster, as it has less commands to process, and also uses less memory. It doesn't really make sense to create a function for something that's so simple. If we look at a slightly longer routine with more commands to process, such as this one here, we're assuming that we start with B and C containing an X and Y coordinate, and that we want to tab the cursor to that position. The macro in this case takes a total of 12 bytes. If we compare that to a function, then the function already takes 4 bytes just to call the routine. So if you're only going to do it once, it's taking up more memory. However, for each consecutive time after that, it's actually only taking up 4 bytes, and the same 3 bytes are reused for the stack. So this time, if we use this routine maybe 10 times in our program, the macro is taking 120 bytes, whereas the function is only taking a total of 53, plus the extra 3 used on the stack. So sometimes we need to decide what our priority is. It might be the case that it's better to combine macros and functions into one routine, and you can also call macros from within another macro. If we take this as an example, a macro to print some coloured text at a particular position on screen, we're using a combination of macros and functions that we call. So the tab to BC and the set colour are both short macros, each of which only take a few bytes each. But the routine to print some text onto the screen is considerably longer, so it makes more sense for that to be called as a function. Another feature you can use within your macros are labels, but they can only be local labels. They only exist within this macro. So in this example here, we're going to print something to the screen a given number of times. B is used as a counter for the number of times that we're given, and the DJNZ will loop round that number of times. Another way to use macros is to create an easy and convenient way to generate the VDP strings that need to be sent. In this example, we're going to define a number of sprites from bitmaps that have already been imported. You'll already be familiar with the RST18 command, where we send a string of data to the VDP. In this case, rather than writing all the numbers out longhand, we've created some macros to generate that data. At first, we have a macro which creates a sprite with a given ID and a bitmap number for its first image. We then have another macro for adding a new frame to our current sprite with a given bitmap number. This makes our code a lot clearer to see what we're actually doing. If we look at these two macros, you can see that there's no actual code being generated, but it's building up a string of data for the VDP commands. So in summary, macros can be quite useful. They can be quicker than calling functions. They can add clarity to your code, and you can build your own custom commands. And they also generate an easy way to put together data strings to be sent to VDP. Hopefully you can now find ways to include macros within your projects.